How do aircraft survive highest altitude flight in thin air? Imagine soaring through the sky where the air is so thin that breathing feels impossible and engines struggle to work. How do planes and pilots make it through these extreme heights? It all comes down to incredible engineering and smart technology. When aircraft reach the highest altitudes, like the Lockheed Senior 71 Blackbird flying around 25,929 meters or over 85,000 feet, they face huge challenges. The air is so sparse that it can't lift the plane or support normal engine combustion. To handle this, engineers design aircraft with sleek, streamlined shapes and use special materials like titanium. The Senior 71's titanium frame can withstand the intense heat caused by air friction at speeds over Mach 3. Engines are also specially built. Instead of regular jet engines, some aircraft use turbojet or ramjet engines that work well in low-density air. These engines are optimized to operate efficiently where oxygen is scarce. Inside the plane, pilots are protected by pressurized cabins or wear full-pressure suits. These suits supply oxygen and keep the body pressure stable, preventing problems like hypoxia or decompression sickness. The cabins are sealed and pressurized to mimic normal atmospheric pressure, making it possible to breathe comfortably. They also have onboard oxygen systems that supply clean air to pilots at all times. Because the outside air is so cold and thin, environmental control systems inside the aircraft regulate temperature and humidity, keeping the cockpit comfortable. Flying at such heights also means control surfaces like wings and tail fins are less effective because of the low air density. To stay stable and in control, aircraft use advanced electronic systems like fly-by-wire technology. These systems help pilots steer and stabilize the plane even when aerodynamic surfaces are less responsive. Over the years, these innovations have pushed the limits of human flight. The development of pressure suits in the 1930s and improvements in engine design allowed pilots to reach heights once thought impossible. Record-breaking flights by aircraft like the Senior 71 in the 1970s and solar-powered planes in the 2000s show how far technology has come. These advancements are not just for breaking records, they also support scientific research, reconnaissance missions, and future space exploration. The key to surviving at such high altitudes is combining pressurized cabins, specially designed engines, protective suits for pilots, and aerodynamic shapes tailored for low-density environments. Each of these elements is a result of decades of progress in aerospace engineering, helping humans explore the most extreme environments in the sky.